Hello everyone. Today we'll be starting the revision of probability distribution. This is the first topic of the 10 marks long chapter of probability. Now, when we talk about probability, we first need to understand when is probability studied, what is the theory behind it, and so on. So, when we talk about the word probability, probability is only studied for a specific situation, and in maths, the work, the job is said to be an experiment. So, it's not that in every case we're able to find the probability. We can only find probability for certain experiment. Such experiments are known as random experiments. Such experiments are known as random experiments. Now, what is a random experiment? Experiment is work. So, random experiment is an experiment in which all possible outcomes are known, but which one will turn up in a particular trial is uncertain. For example, like a coin. I know that when I toss a coin, either head will appear or tail will appear. But which one will appear in this case is unknown. If I pick up a card, I know either a red card or a black card will come. But which one will come when I'm going to pick up the card this time? I'm unsure. I know that when I suppose throw a dice, it's either going to be one or two or three or four or five or six. But if I'm throwing it right now, what will come? That's unsure. So, an experiment in which all possible outcomes are known, but which one will appear in a particular trial is uncertain, is known as a random experiment. Now, as I'm saying all possible outcome, the collection of all those possible outcome is known as sample space. So, sample space is the collection of all possible outcomes. All possible outcomes. And in our first topic, the most important thing for us to write is sample space, right? So, if I have coin, the formula is 2 to the power n, where n is the number of times you're throwing a coin, tossing a coin, or number of coins you're tossing. For dice, the formula comes out to be 6 power n, where n is either the number of dice or number of times a die is thrown. So if I have one coin, the sample space S will be head or tail. If it's two coin, then the sample space will be two coin HT, HT. So it will be HH, HT, PH, PT. If I have three coins, sample space 2 to the power 3, there will be 8 outcomes. So again, the third one can either be head or tail. H, 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 T. H, T can be either head or tail. H, T, H, H, T, T. T, H, it can be either head or tail, right? It can be either head or tail. So T, H, H, T, H, T. T, T. It can be either head or tail. So T, T, H, T, T, T. Same for 4 coin, it will be 2 power 4, 16 outcome, and so on. For dice, if I have only one die, then there will be 6 power 1, that is 6 outcomes. If I have two dice, the sample space will be, if the first outcome is 1, the second can be 1, 2, 3, 4, 5, 6. Same 2, 1 to 2, 6. 3, 1 to 3, 6. 4, 1 to 4, 6. 5, 1 to 5, 6. 6, 1 to 6, 6. There are 36 outcomes. Now, when I'm talking about 36 outcome, when I'm talking about 36 outcome, when I'm talking about 36 outcomes, what will happen is the sum starts from 1 plus 1 to, and the last goes up to 6 plus 6, 12. The sum goes from 2 till 12. The sum goes from 2 till 12. Now, the numbers like 1, 1, 2, 2, 3, 3, 4, 4, 5, 5, 6, 6, they are known as doublets. Doublet is 1, 1, 2, 2, 3, 3, 4, 4, 5, 5, 6, 6. These are known as doublet. These are known as doublets. Yes. Now, from this category, there can be mixture of coin and dice. Suppose one coin and one dice is thrown. In that case, the sample space, coin is H. In that case, the dice can be 1, 2, 3, 4, 5, 6. If I get tail in the coin part, then in the dice part, I can again get from 1 to 6 anything. So T1, T2, T3, T4, T5, T6, and so on. Now, suppose if I say a coin is tossed until tail appears. So as soon as you get tail, you'll stop. But if you are not getting a tail, you're not supposed to stop. So suppose I threw a coin, H or T. If I'm getting tail, I don't need to throw it again. But if I get head, I need to throw it again. When I throw it again, I can either get a head or I can get a tail. If I get tail, stop. But if I'm getting head, again throw H or T, right? So the sample spaces, you're supposed to stop when you get tail. So I can get tail in the first game and the game ends there. Or I get tail in the second game. But why did I play the second game? Because I did not get tail in the first game. That means I got head in the first game and I got tail in the second game. Or I can get tail in the third throw. So H, H, T. Or I can get it in the fourth throw and so on, so on. A coin is tossed until head appears, until head appears or tail appear 3 times in succession. Or tail appears 3 times in succession. That means I have to stop as soon as I get a head, or I have to stop when I get tail 3 times. So it can so happen that I get head in the first game, head, and the game ends. Or I can get head in the second game. But why did I play the second game? Because I did not get head in the first game. That means in the first game I got tail, and then in the second game I've got head. Or I got head in the third game. Or I did not get head in the 3 games, but I'm not allowed to play the fourth game because if tail appears 3 times together, I have to stop. So my sample space ends here. My sample space ends here. Now, similarly, a question could have been asked that a game is played until you win or lose 4 times in succession. So W stands for win, L stands for lose. So my sample space will be, I may win the game in the very first possibility game, or I won the second game. But why did I play the second game? Because I did not win in the first game. That means I lost the first game, I won the second game. I lost the first 2 games, I won the third game. I lost the first 3 games, I won the fourth game. Or I lost 4 games. And if I have lost 4 games, I'm not allowed to play again. I need to give up. So these are the most famous sample spaces we'll talk about, right? Now, what will happen with these sample spaces is we are going to define a function. What is a function? What does function do is if I have 2 sets, say A and B, function will form pairs so that each and every element of the first set will be related uniquely to an element of the second set. That means every member of the first set has to form a pair, and they can only form a pair. They can only get a value 1, right? They cannot get 2 different values. They can only get 1 value, right? So if I have here For example, the sample space of one coin, HT. And I say that the function is counting the number of heads. This will be mentioned. So my function is counting the number of heads. My function is counting the number of heads. So if I'm counting number of heads, then my second set is always going to be real number. What is real number? Everything except root negative, even root negative, and denominator 0. Rest everything is a real number, fraction, decimals, everything. So my first set is always going to be a sample space. My second set is always going to be a real number. So what will happen in this function? This function will form pairs of everyone in the sample space. That is every sample point to a real number according to a given specific condition. What is the condition in this particular case? Number of heads. So my first sample point is H. In H, how many head did I get? 1. So H will be awarded the value 1. So I have formed a pair H1. Now, when I got the sample point T, how many heads did I get? I got 0 heads. So T will be awarded the value 0. My second pair is T is 0. Right? There is no more element. There are no more elements in the sample space. So it ends here. But there are more elements here. Right? Clear? So this function, the function which associates to every element of the sample space a real number, is known as a random variable. So what is a random variable? क्या होता है random variable? Random variable is denoted by capital X and it is a real valued function. It is a real valued function. राइट क्या करता है ये? सैंपल स्पेस का जोड़ी बनाएगा रियल नंबर के साथ. क्योंकि फंक्शन है, दैट मीन्स एवरीवन इन द सैंपल स्पेस हैज टू बी पेड. नो वन कैन बी लेफ्ट बिहाइंड. दैट्स व्हाई दिस इज नोन एज डोमेन. This is known as domain. So domain of a random variable is sample space. Domain of a random variable is sample space. Now, this is known as codomain. The second set is known as codomain. But do we use everyone in the second set? No, we just one example, -1, -2, half. No, none of those numbers are related. We only use two numbers, 1 and 0. So the numbers that you get as an answer is known as range. So range is always a subset of codomain. Range is always a subset of codomain, right? So what is a random variable? It is denoted by capital X. It is a real valued function which associates to every element in the sample space with a real number. The domain of a random variable is sample space. The range of a random variable is a real number, a subset of a real number. Clear? The codomain is a real number itself. Now, we have formula for number of functions. Number of function is second set to the power first set. But in this case, we cannot have because the second set has infinite possibilities. Clear? Now, what is a random variable? It is a real valued function. What is the domain? Sample space. What is the range? Subset of real numbers. Now, what will happen is every sample space will be awarded something, will be awarded a value according to a criteria. Suppose if I take this sample space of 2 coins. Sample space of 2 coins. So the question will tell you what is the random variable. Suppose this is number of tail. It is number of tail. The question tells you. So what will happen is every sample point can be allocated a value according to this condition, right? So HH, how many tails are here? There are 0 tails, right? In HT and TH, in both the cases, there is 1 tail. In TT, how many tails are there? 2. So range of X, or if you say possible values of X, in our cases 0, 1 and 2. And now, when we form a table which consists of all the values of X with their corresponding probability, so X 0, 1 and 2. Now 0 is awarded to how many people? 1 out of 4. So 0 probability 1 by 4. 1 is awarded to 2 numbers out of 4. So 1 will have probability 2 by 4. 2 is awarded to one number out of 4. So 2 has probability 1 by 4. So this particular table is known as probability distribution. Is known as probability distribution. So what is probability distribution? Probability distribution is the table where all the possible values of x are written with their corresponding probabilities, provided they satisfy two conditions. First, none of the conditions are imposed on the random variable. Random variable can be anything, but the conditions are imposed on the row of probability. So since it is probability, each one of them has to be non-negative, and sum of the probability has to be 1, which in our case is true. So a probability distribution is a table where all the values of x are written with their corresponding probabilities, provided they satisfy two conditions. First, all the probabilities are non-negative, and second, sum of the probability is 1. Now, in this case, we directly written 4 out of 1, 2 out of 4, 3, 1 out of 4. Why? Because all of them had 2, 2, 2, 2 sample point. But if the quantity is unequal, in that case, we cannot find the probability of this. For every head, we write half. For every tail, we write half, if they are unbiased. But if it is biased, then that will change, right? So suppose if the question says that there is a biased coin, head appears 75% time. Head appears 75% time. So probability of getting head is 75%, that is 3 out of 4, and probability of tail will be 1 out of 4. Now x represent number of heads. X represent number of heads. So in this case, there are 3 heads. What will be the probability? Now, in this case, I cannot write 1 out of it because H and T have different probabilities. I have to calculate now. So, first H, I'll have probability 3 by 4. And second H, 3 by 4. Third H, 3 by 4. So, 3 by 4 has to come thrice. So, this will be 3 by 4 whole cube. For situations of this, and this, there are 2 heads. So head has to appear, probability of head will appear twice, and probability of tail will appear once. And how many of them are there? 3. So multiplied by 3, right? Next, probability, these. All of them has one head. How many times? Thrice. In that, head comes once and tail comes twice. Yes, and then in TTT, there is 0 head. TTT, each one of them has probability 1 by 4. Each one of them has probability 1 by 4, and it only appears once. So if it is a biased coin, we need to write the individual probabilities multiplied by the number of time it occurs. Clear? So in this case, if I have T, the probability will be 1 by 2. To get HT, probability will be half into half, 1 by 4. If I have to get HHT, it will be 1 by 2, 1 by 2, 1 by 2, 1 by 8. If it is this, it will be 1 by 2, 4 times, and so on. Yes? So, what did we define? Random variable. Now, what is a random variable? Random variable is a real valued function whose domain is sample space and range is a subset of real numbers. Then probability distribution. It is a table where all the values of x are written with their corresponding probabilities, provided they satisfy two conditions. First, probability non-negative, and second, sum of the probability 1. Right? Now, from this table, we are able to calculate everything regarding statistics. So in statistics, we talk about mean, median, and mode. So mean of random variable or expected value of random variable denoted by E of x or mu is sum of every x multiplied by the probability. Okay, so if they ask you mean number of heads, expected number of head, that means number of head is your x, and for that you are finding the expected value, that is sum of x into px. If the question says find e of x square, so it will be sum of x square into probability. Only x gets squared. If it is x cube, it will be x cube into probability. Then we have standard deviation of x denoted by sigma. The actual formula is E of x minus mu whole square. But while doing the sum, we use the formula E of x square minus E of x whole square. Variance of x denoted by sigma square. So only the root over part goes away. Rest everything remains the same. Yes. Now, there are a lot of properties. The properties are, first, expected value of anything other than x. Everything remains as it is, only the e goes to x. So if I have, for example, that mean of x I got as 4, then expected value of say 1 minus 2x will be 1 minus twice e of x. 1 minus 2 into 4, that's minus 7. E of x, that is mean, can be positive, negative, anything. But standard deviation and variance can never be negative. Impossible. Second, if I have to find standard deviation of ax plus b, whatever is added or subtracted, that gets vanished. The only thing that remains is what you have multiplied or divided. So it will be a into standard deviation of x. And since I'm not sure about the sign of a and I cannot have negative answers, so it is absolute value of a. For example, if standard deviation of x is 3, then standard deviation of 1 minus 2x will be only 2 into standard deviation of x, that is 6. If I have to find variance of ax plus b, again, whatever is added or subtracted, that is removed. Whatever you are multiplying or divide, only that remains, and even that gets squared. So it will be a square into variance of x. A square into variance of x. So for example, if variance of x is 3 and now I want to find variance of 1 minus 2x by 5, whatever is multiplied and divided, only that remains, and even that gets squared into variance of x. So it will be 4 by 25 into 3, 12 by 25. Now, this is actually what we use while proving the formulas. So it comes prove that standard deviation of x e of x square minus e of x whole square. We have to actually prove the formula, but this is a derived formula. So from the actual formula, we need to get this. So proof, let mu be the expected value of x. That means e of x and mu are same thing. Now, standard deviation of x. Standard deviation of x. The formula is expected value of x minus mu whole square, the original formula. Opening the whole square, a square minus 2ab plus b square. Now, as we know with this property, e only goes to x. Rest everything remains as it is. So, e of x square minus 2 mu e of x plus mu square. So this is e of x square. Now, e of x can be written as mu e of x square minus 2 mu square plus mu square. So e of x square, sorry, the root over I forgot. minus mu square. Putting the value of mu again, e of x square minus e of x whole square. E of x whole square. I hope it's clear. Any doubt till here? Kindly respond in chat. Any doubt till here? Okay, let's move to the sums then. First, a random variable x has the following probability distribution. A random variable x has the following probability distribution. So we know that for a probability distribution, it has to satisfy two conditions. First, sum of all the probabilities has to be non-negative, and second, sum of the probability is 1. So non-negative thing won't come to any use here. But since x is a random variable, since x is a random variable, that means sum of the probability will be 1. So if I add all of these, I should get 1. If I add all of this, I should get 1. So what do I get by adding them? 10k square plus 9k minus 1 is 0. Let's do the middle term. It will be 10k minus 1 into k plus 1. So first, either k is 1 upon 10 or k is minus 1. But k is written in the probability section, so it can't be negative 1. So this is not possible because probability cannot be negative. Agreed? So Roman 1, k is 1 by 10. This is done. K is 1 by 10. Now, number 2, probability x smaller than 3. X smaller than 3. X should be smaller than 3. So these are the three possible values that we have. So that means x can be 0 or 1 or 2. Probabilities 0k, 2k, 3k. Now we put the value of k 1 by 10. You can write it in decimal or simplest form of fraction. Both of them works. Done. Third, probability x more than 6. So more than 6, we only have one number 7. One number 7. So this is basically P of 7. P of 7 is 7k square plus k. So 7k square 1 by 100, k 1 by 10. Answer 0.17 or 17 by 100. Any which way you can write. Done. Fourth, probability x lies between 0 and 3. So between 0 and 3, how many values are there? There are only two values. So it will be P of 1 plus P of 2. That is 3k. So 3 upon 10. 3 upon 10. All of you clear? Next. Next. So in this case, the box, the probability distribution is not given directly, but it is given in a formula, in a function format. So if you look at here, it tells you x can be 0, it can be 1, it can be 2, it can be 3, it can be 4. Otherwise, we don't consider because the probability is 0. That means the possible values of x are 0, 1, 2, 3, and 4. Right? Now we need to write the corresponding probabilities from the function. It says for 0, 0.1. For 1 and 2, it is kx. But now we know the value of x. When I've written kx here, in this case, x is 1. X is 1. So here I can write instead of x 1, k into 1, that will be k. Now for x equal to 2, again the probability is kx. Here I can put the value x equal to 2. So k into 2 probability will be 2k. For 3 and 4, the probability is k into 5 minus x. But we already know the value of x. Here x is 3, so it will be 2k. Here x is 4, it will be 1k. This is our final table. Now we want to find the value of k. We want to find the value of k. We want to find the value of k. So since x is a random variable, so sum of the probability will be 1. Sum of the probability will be 1. So if I add all of them, I should get 1. If I add all of them, I should get 1. So zero point 0.1 plus 3k, 5k, 6k. From here, 6k, 0 0.9, k, 0.9 by 6, 9 by 16. 3 threes are 320. So k is 3 by 20. Yes, k is 3 by 20. Now, this is done. What is the probability that you study at least 2 hours? At least is minimum 2. That means I now want to find probability x more than or equal to 2. So from 2, we have how what? P of 2, we have P of 3, we have P of 4. If I add their probabilities, it will be 5k. Put the value of k. So it is 3 by 4. It is 3 by 4. Exactly 2 hours. Exactly 2 hours. Exactly 2 is P of 2. 2k. So 2 into 3 by 20. That is 3 by 10. 3 by 10. Then at most 2 hours. At most 2. At most 2 is maximum 2. So lesser than equal to 2. That will be P of 0, P of 1, P of 2. P of 0, 0.1. P of 1 plus P of 2 is 3k. 1 by 10 plus 3 into 3 by 20. 11 by 20. 11 by 20. You can express each one of them in decimal if you wish to. That's your call. Let's move to next sum. It's a very famous sum. So early in class 11, we have learned that if there are a lot of equal to sign, then always assume the value to be something, right? So since there are so many, it says that x is a random variable which assumes these 4 values. So x has only these 4 possible values and the probabilities have a connection given twice p of x1 equal thrice p of x2 equal p of x3 equal 5p of x4. Let us assume that this is k, right? So each one of them will be equal to k then. So from here, probability of x1 is k by 2. Thrice p of x2 is k. So from here, p of x2 will be k by 3. P of x3 is k. 5p of x4 equal k. So from here, probability x4 will be k by 5. Now we know that x has only what? 4 possible values, x1, x2, x3 and x4. And they have corresponding probabilities. x1 we got as k by 2. x2 we got as k by 3. x3 we got k and x4 is k upon 5. Right? Now, since it is a random variable, so we know that some of these probabilities will be 1. Some of these probabilities will be 1. So, add them k by 2, k by 3, k, k by 5 is 1. LCM 61 by 30k equal 1. So from here, k will be 30 by 61. K will be 30 by 61. The question asked us to find the probability distribution of x. So finally, therefore, probability distribution of x. X has four values, x1, x2, x3, x4, p of x. So let's calculate here first. P of x1, k by 2, that is 15 by 61. P of x2 is k by 3, that is 10 by 61. P of x3 is k. So as it is 30 by 61. P of x4 is k by 5. So 1 by 5 into 30 by 61, that is 6 by 61. So now in the table, we don't do any calculations. We always write the final answer in the table. So probability of x1, 15 by 61. Probability of x2, 10 by 61. Probability of x3, 30 by 61. Probability of x4, 6 by 60. Sometimes it says that write the function. Write it as a function. So if you have to write it as a function, then it will be x1 15 by 61, x2 10 by 61, x3 30 by 61, x4 6 by 61, where domain is x1, x2, x3, x4, and range 15 by 61, 10 by 61, 30 by 61, 6 by 61. In case they ask us to represent it as a function. In case they ask us to represent it as a function. Is it clear to everyone? Please respond. Is it clear to everyone? Please respond. Let's start. Next question. Give it a try first. Okay. Now the question says the random variable X. Does anyone have a value? P value? Does anyone have a value? Please respond. Does anyone have a value? Okay, let's see. So the random variable X can take only the value 0, 1, 2, 3. So there are four possible values 0, 1, 2, and 3. The question says that the probability for 0 and 1 is same as P. The probability of 2 and 3 are same, but we don't know what that probability is yet, right? So let us assume that probability of 2 and 3 are both say Q. Now the table X has possible value 0, 1, 2, 3. For 0 and 1, the probabilities are P. It's given in the question. For 2 and 3, we have assumed the probabilities to be Q. Since X is a random variable, so we know that sum of the probability will be 1. That means sum of these four will be 1. 2P plus 2Q equal 1. P plus Q half. From here, Q will be 1 by 2 minus P. Yes. So there are two unknown variables P and Q. So we needed two conditions. One, sum of the probability 1. And one more condition the question has provided us. One more condition the question has provided us. One more condition the question has provided us. Right? Given summation pi xi square. Probability into square of the number is equal to twice pi into xi. So pi into xi square, p square, sorry, 0 into p, 1 square into p, 2 square into q, 3 square into q, twice, 0 into p, 1 into p, 2 into q, 3 into q. That's all. So p, 4q, 9q, 2p plus 3 plus 2, 5, 5 into 2, 10. So 13, 10 comes here, 3q equal p. Now the value of q can be replaced from equation 1. 3 by 2 minus 3p equal p. 3 by 2 equal 4p. So p will be 3 by 8. P will be 3 by 8. The question only asked us to find the value of P. 3 by. If the question would have asked us to complete the table, then we would have put this value, use this value P to first find Q, and then we would have replaced it in this particular table. If the question would have asked, which in this case it hasn't. Yes? Next. It's a very famous sum. A person plays a game of tossing a coin thrice. So as soon as the question says that you are tossing a coin thrice, the sample space is fixed. 2 to the power 3, 8 outcomes. So H, 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 T, H, T, H, H, T, T, H, H, T, H, T, 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 H, T, T, right? Now, for each head, he gets rupees 2, and for each tail, he has to give rupees 1.5. Remember, if in probability question you are talking about losing and getting money, X, your random variable, will always be money, no matter what the question says. Okay, X is always going to be money, always. If it is a question about money. So here, let X represent. Okay, we don't need to because the question is already mentioned. Let X denote the amount gained or lost by the person. So I don't need to mention. But even if the question would not have said X is always price, X is always money, fixed. right? Now, it's a normal coin. So for every head, we get half. For every tail, we get half, right? And in case of money, for every head plus 2, for every tail minus 1.5. Show that x is a random variable. How will I show it? X is a random variable. How do we show that x is a random variable? If I can show that sum of the probability is 1 and everyone is getting a unique value, then it is a random variable. And then I need to write it as a function. So for every sample point, for h, x will be amount plus 2 plus 2 plus 2, that is 6 rupees. And probability head, 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 1 by 8. Yes. For any of the one event where you are getting two heads, right? 1, 2, and this case. X will be twice you are getting 2 rupees and once you are losing. And once you are losing. And once you are losing. So it will be 2.5. And probability in each case, 2 heads, 1 tail. So it will be 1 by 8 for each of them. For cases where there is 1 head, okay, 1, 2, 3. In these three cases, x, once you got 2 rupees and twice you lost 1.5. That's minus 1. And probability would be for head, tail, and tail. In each case, 1 upon 8. For the case where you haven't even got a head, there's only one case as such. X, lost 1.5, lost 1.5, lost 1.5. So minus 4.5. And probability would be 1 by 2, 1 by 2, 1 by 2, 1 upon e. So x will be, what are the possible values of x? 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 6, 2.5, minus 1, minus 4.5. Agree? So we can conclude. We need to show that it is a random variable since each element of the sample space x takes a unique value. Therefore, x is a random variable. X is a random variable. How will I represent it? X, 6 only once, 2.5 you got thrice, so 3 upon 8. Minus 1 you got thrice, 3 upon 8. And minus 4.5 you got 1, so 1 upon 8, right? So domain 6, 2.5, minus 1, minus 4 point, sorry, range, not domain, range, values of x. Na? So range, that's your range. Domain is sample space. This is the range. I hope it's clear. Now, we'll use these things to find mean and all. Let's start. A coin is tossed until a head appears or the tail appears 4 times in succession. We just wrote the sample space for such a scenario. A coin is tossed until a head appears. So a head may appear in the first game, right? Or head appears in the second. That means you got tail in the first. Or head appears in the third game. Or head appears in the fourth game. Or head does not appear, right? A coin is tossed until a head appears or tail appears 4 times in succession. So you have stopped the sample element, sample point, if you have got a head or you have got four tails continuously. Find the probability distribution of the number of tosses. Now, X is always for which you're forming, finding the mean, finding the expected value, finding the probability distribution. Since here you're finding the probability distribution of number of tosses, so let X represent the number of tosses. So for H, how many times did we throw the coin? Only once. And to get that value head, the probability is half. For TH, we threw the coin twice, right? And probability to get tail in the first 1 by 2, to get head in the second 1 by 2, that's 1 by 4. For TTH, X, you threw the coin thrice, probability 1 by 2, tail 1 by 2, head 1 by 2, that's 1 by 8. For TTTH, you threw the coin four times, P of X, tail, 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 head, 1 by 16. And last, for TTTT, we threw the coin again four times, P of X, half appears four times, 1 by 16. Right? So, probability distribution of X. X. What are the possible values we can see? 1, 2, 3, 4, 4. So, 1, 2, 3, and 4. Probability. For 1, the probability is 1 by 2. For 2, the probability is 1 by 4. For 3, the probability is 1 by 8. For 4, we have two of them. So 1 by 16 plus 1 by 16, 2 by 16, that is 1 by 8. That is 1 by 8. Yes. So till here, what we learned is how to write sample space, what is random variable, their domain and range, and how to form probability distribution, which should satisfy two conditions. The probability row should be non-negative and sum of the probability should be 1. Now, using this table, what we do is we find mean and variance. For that,